Hello, everyone. This is part 2 of my extremely interesting discussion with Tim Dawson. Tim, so I think that the first part of our discussion was important to outline the big picture and, just to understand where manufacturing could be going in general. But I think that now we can go into details, and I think that we should explore some key technologies, key from the perspective of our customers and our partners. And I think one of those important technologies that are already shaping manufacturing business is the digital twin technology. And we see that digital twins have a huge potential for optimizing how you actually deploy machines and how you are, making your investment choices and so on. We definitely know that digital twin adoption will be growing in the coming year. But maybe you could guide us what we should be expecting in development of this technology.
Mm-hmm. Sure. So from a manufacturing and automation perspective, digital twins are really an extension of engineering, not just an IT concept. I think the true value of digital twins lies in supporting engineers during that design, commissioning and operation side of things. So helping to identify risks early on, and reduce, potentially costly reworks in manufacture and production. So for example, they sort of allow that what if validation, enabling comparisons between different options before, hardware is physically ordered and money is spent in a way. So, that's a true benefit, of course. I'd say they also extend well beyond mechanical simulation, to modeling, electrical systems, drives, motion control, process behavior as well. So in some cases, real PLC programs can run on virtual machines, letting engineers test and refine control strategies before any physical equipment arrives. So in effect, digital twins almost becoming more of like an onboarding platform for the next generation. It can be used to train workers in a safe virtual environment, and effectively passing on, I'd say, expert knowledge into new hires. So it turns a technical asset into more of a human capital asset as well. I would say there are clear limits to it right now. If the models become too complex or costly to maintain, they won't be used. So in industry, the quickest solution still needs to prevail. It needs to be pragmatic. Too much complexity can create further barriers to adoption in a way. So looking towards 2026, I'd say the digital twins that will endure will be those that are more easily integrated into existing engineering workflows. So supporting real decisions rather than just visual displays and simulation. So AI, I think, will enhance digital twins, but it will be the engineering reality off the back of that ultimately determines which one's the most successful.
That's a very interesting point about the complexity of those solutions, because I have a feeling that many of those software technologies are going the other way. I mean, the complexity only grows, but so according to you, the simplicity is the key factor to implementation.
I think simplicity for the end user ultimately. So trying to ease that adoption curve, the potential for people to employ more adoption, more automation, to incorporate, perhaps more complex thinking into their automation strategies, but through simplifying, through using, digital twins and things. Yeah.
And by the way, another way of implementing digital twins that we have seen already is actually when the digital representation of the factory is connected to the physical one. and basically the system can learn about the performance of the factory or of the machine, and then some potential for optimization is visible, right, for the engineers. So for sure, this is going to be a big addition to the whole scope of potential applications. But maybe we can also discuss where do you see digital twins being adopted the most, right? So we have many industries that can benefit from this type of technology. But according to your research, where do you see digital twins adoption accelerating?
I mean, they're already being used across really a wide variety of industries, as you mentioned. So, but typically it's a bit more focused in practical applications, perhaps, rather than full virtual replicas, although that's obviously changing over time. So they help to validate design, commissioning and operation and production of the production process before it's built. So, and as I said before, some PLC code and things is already being run on virtual machines to test motion profiles, reduce startup risks, all those sorts of things. But depending upon the industry, we're seeing them being used in different ways. So in automotive, for example, they really help to optimize production lines, simulate vehicle variants, potentially analyze bottlenecks in production. In battery production, they assess thermal behavior in batteries almost and the process stability around production. In energy, digital twins are model assets and turbines and pipelines, combining those physical models with data to predict degradation and improve the maintenance flow of those systems. So some of the things we've spoken about already in our previous discussion together, but those are good things. In aerospace and large scale infrastructure, digital twins can help validate assembly of those complex structures and complex things being manufactured. So that's another thing. Logistics, another good example, really modeling material flow through a facility. So in those sort of instances, optimization really revolves around maximum throughput, identifying bottlenecks, minimizing those, and really getting packages, parcels, whatever it may be, out as quickly as possible. So lots of things there. And I think finally in sort of food and beverage manufacturing for process optimization, it's a key thing. More of a process automation side of things, companies using digital twins to simulate how dough moves through an extruder, or simulating cooking temperatures, mixing speeds, those sort of things to make sure the ultimate integrity of the product is as good as it can be as well. So I would say across all of those industries, digital twins are really designed to try and reduce uncertainty in those complex situations where, unplanned for changes or problems can be very costly. So, design decisions need to be very confident. You need to be comfortable that what the machine that you're producing or the end product that you're producing is as good as it can be. So that's where digital twins come in to support the operational and investment decisions, not just simulating or visualizing a plant.
Yeah. And, in our first part of our conversation, you explain, how, generally speaking, the software is augmenting the possibilities in manufacturing. And I think this is a perfect example of that, right? So digital twins are one of those technologies that bring value with a proper software approach, right? So you want to have a software that is somehow utilizing the data from the hardware, from the production, and then you can actually take some specific decisions based on that data. And I think that digital twins are already, as you said, proving to be extremely successful in that, right? There is one immediate challenge that pops up in this situation, is that you have your physical production, and then more and more you connect that physical production with different softwares, different IT systems. So naturally, the cybersecurity problem appears. So in the past, we didn't have that much to do with the cyber threats in manufacturing. But definitely this is visible for the last couple of years, that cybersecurity is becoming a huge problem for manufacturing companies. More and more customers are interested in how to protect their factories from cyber threats, right? So maybe you can also outline what's going on in this area. So how the cybersecurity is developing in 2026.
Sure. So I think really traditionally, industrial cybersecurity was very focused on preventing machine downtime and threats that way. So while availability remains critical, the bigger risk now is actually loss of control and trust as we spoke about, IT and OT worlds start to converge. So now cybersecurity is no longer just about protecting data or networks, but really ensuring operational integrity within your facility as well. So manipulated control logic or models can keep systems running, but in unpredictable ways, which can be dangerous, potentially more so than a complete shutdown. So you don't want nefarious things going on in your production process necessarily. So manufacturers must really focus on protecting their control systems, their data integrity, and supply chain access. So limiting that to people that they want in there and not those that they don't. So the real concern is about who can change what, under what conditions, and with, I guess, the proper accountability. So making sure that's integral and safe. You could think about cybersecurity tools being like locks, protecting valuable assets. So many factories have them, but they're not always in place necessarily. So, or maintained properly or secured properly. So before advancing really to more sophisticated security, manufacturers really must ensure that those basics are being handled properly. I think in the future, we expect cybersecurity will be as much about awareness as technology. So you need to recognize all of your digital assets within a facility as real assets and protect them properly with the same care that you would those physical ones. So that convergence of physical and digital is important, is happening, but you need to secure both, not just one in that process. So, and I think the other big challenge is you can't secure assets if you don't recognize them properly. So recognizing digital assets as a potential threat and a problem as well. It's moving cybersecurity to be not just like a cost center or problem, but more like a full-blown certificate of trust around you know your process and plant.
And we spoke in detail about various ways of implementing AI. And what can already happen is that those AI systems might make like certain decisions on the factory floor, right? So they can actually influence the production process itself. And this is clearly also a problem of cybersecurity, because if you are not protecting your digital assets, those assets actually can take the decision on the factory floor. So essentially you are heading for disaster in many cases, right? Of course, this is not like a huge problem today, because such autonomous systems are not yet that popular. But we can expect this is going to be something accelerating as well. Therefore, the cybersecurity is not an option anymore.
That's correct, yeah.
So I think the another area that interests our customer base is sustainable production. It has become a very important factor in decision making. So there are various regulations that are affecting that, but obviously also I think that the huge trend is kind of awareness, general awareness of the societies. So this is becoming a very important topic for manufacturing companies. And I think that, again, that is one trend that is not going anywhere. we will be seeing more and more topics around sustainability appearing in manufacturing industry across different segments. Mm-hmm. So I'd like to use your experience in that area. And I'd like to understand, like, what do you expect, how the future manufacturing will look like in terms of enabling this sustainable development?
So, one of the challenges that we see around sustainable development goes back to the labour shortages that we discussed earlier. So the fact that the ageing population trend has emerged in many countries, and I'd say furthermore, people's willingness to work in manufacturing jobs that are maybe repetitive or involve hazardous environments, those sort of things is declining. So that's definitely being challenging that whole sustainable and future of manufacturing in a way. I'd say there's also quite a strong and increasing, in a way, structural mismatch between labour supply and demand. So, for example, the mismatch between an employer's task requirements and an employee's skill capability, especially given the quick knowledge iterations and the changes that we're seeing, the rapid changes that we're seeing over time in how those things are developing. So mismatch between protected workers' leave rights and demand during holidays is like causing peak challenges at times when people maybe want to work less. So these factors will definitely continue to bother manufacturers in 2026 and beyond.
This is sometimes a factor that is a bit omitted when we discuss sustainable development, because there tends to be a focus on energy efficiency and things like that. And of course there are like certain actions you can take in there that can actually support let's say your movement towards sustainability. But this labor problem, I think that this is something very, very hard to address, as you said, especially, we don't see these trends of lower birth rates to be in any ways reversed, right? Mm-hmm. So I think that this is a problem for decades, for not only for manufacturing companies, but for sure here as well. So what is your opinion about how technology might address this issue?
I think there's three big things that we can point towards and lean on here. So definitely adopting more technology to optimize efficiency is one critical thing. So just generally that deployment of automated equipment. So replacing repetitive tasks with industrial robots, with collaborative robots, to reduce reliance on basic talent, basic skill requirements. So that's definitely one thing. Adoption of AI and digital tools we've touched on already, but really doing that to improve throughput and efficiency and intelligent execution of management systems, and really, I'd say, trying to reduce your reliance on some of your more skilled workers. So, softening the demands on them through adoption of digital tools. I'd say standardizing more operating procedures is another good thing that companies can do. So really trying to simplify that high-end technology operation steps to develop visual interfaces with lower skill thresholds. So operators that are on the line can do more, can work with machinery and equipment in a better way, without perhaps needing a fully qualified engineer to support them doing those sort of things. So making those sorts of things easier. So that's one. That's adopting technology and creating operational, optimizing efficiency that way. The second thing is really just talent development more broadly and enhancing their competencies. So that could be internal skills training. It could be online education platforms, trying to upskill your existing workforce, to make them better at the jobs, that they're doing. And then I'd say the third important thing for companies is really enhancing employment models and better attracting talent. So that could be through more flexible employment and external collaboration with partners potentially. So seeking additional workers to introduce short-term workers to support during challenging periods where there's perhaps, especially seasonal places where it's extra busy, perhaps regional, cross-industry, cross-regional employment. So recruiting talent from other manufacturing industries to support your processes, and then potentially optimizing incentives as well. So improving salary packages for skilled talent, providing career advancement paths for all staff is a good thing, and then just enhancing those sort of welfare guarantees around job security and those sort of things should help, hopefully.
Yeah. One thing, again, discussing how technology is involved in all of that. The one thing that we see is, for example, rise of remote maintenance or remote diagnosis of problems and so on, right? Mm-hmm. So this is something that fits your explanation, because you could imagine that you might have like a talented engineer in one place that can actually solve problems in another factory and so on. And definitely we see that this is an example of how you can somehow solve this issue. It's an indirect way of solving the problem of the labor shortage, but definitely technology has a certain ability to help in that regard. But when we talk about sustainable development, clearly labor shortage is not the only factor there. And there is more and more discussions around the circular economy. So this is one of the most natural answers to the problem. And circular economy has become already a sort of a phrase that you hear everywhere. But then again, it doesn't seem to be like properly used yet. Mm-hmm. But my expectation would be that circular economy will become an important trend in the coming year. So maybe you can explain how you see that developing.
Sure. So I think when you think of it that way, there's elements of the circular economy really in trying to close production loops. And it can be a real challenge in the manufacturing environment, especially, I would say. So there's certain places where it's done well. There's other places where there's definitely still progress to be made. And we'll talk a bit about all of those. So, really closing those production loops it's about linking this internal cycle of like the resources that you're inputting, using those properly in the manufacturing process, minimizing waste, discharge and output that way. And then potentially even down the road, having the ability to recycle your end product once its useful life has come to an end. So there's a lot of different kind of strategic dimensions that need to be taken into consideration when you think about that. So if you start at the very beginning with that source control, laying the foundation for that control, closed loop production by minimizing waste at the source is obviously the best thing that you can do. So, that could be trying to adopt, more modular designs. It could be, having designs that can be easily assembled or disassembled and, parts replaced if there's products. So instead of having to replace a whole unit, you can replace parts of a unit potentially. So, but that requires, extra work, often and unified interface standards and things for products that can be sometimes challenging. And some companies choose not to do that, shall we say. So that's one aspect. The second aspect is really process optimization. So maximizing resource use and minimizing waste during that production process. So trying to promote on-site real-time circulation of your own, raw materials going in and ensuring that that's as efficient as it can be. And then think at the end of the life of a product. So ultimately then perhaps, when it's past its useful life, getting to that end of life recycling is an important aspect as well. So, but that requires extended thought on the original manufacturer's part as well. So that becomes then a problem across the supply chain. So that can be a big thing that everyone should be responsible for, and it is not one single person's responsibility, but can act as a barrier to that. And then finally, really digital empowerment. So bringing data as a driver to improve transparency around, those different stages that I mentioned there, trying to monitor efficiency in those processes, control those processes to make it a more closed loop system that you can understand and appreciate truly what's going on. So that could be linking it to your ERP systems or your MES systems and bringing things in there. So it's a big task to do all of that properly. Manufacturers need to integrate their own internal resources across multiple departments within their organization, potentially with partners that are supplying products to them potentially as well, to form this more linked, complete supply chain approach to the product ultimately. There are certain industries that do that really well. Something like the battery industry demonstrates this really joined up supply chain where everything from sort of resource extraction of the raw materials to the cell production to the battery assembly to ultimately waste recycling once the batteries are spent, and then the material reuse and regeneration, that is actually being done quite successfully globally now. But it is a challenge, and it's not easy to be done worldwide. So, it's not possible quite so easily in industries that are less joined up, shall we say.
So the battery industry is a great example that you just gave because they had to do that well, right? Because the cost of raw material is high, and then of course the waste this could produce is problematic. So I think that we can all learn from the lithium-ion battery market segment in relation to circular economy. But this is a huge challenge, and it's not like you can change your factory from one day to another. So I assume that there are some things that manufacturers have to take into consideration, right?
Correct. So yeah, definitely on the flip side, looking beyond battery, it's definitely more challenging to do this across manufacturing more broadly. So technical barriers often exist. So these techniques that the battery industry applied, for example, cannot be applied across all manufacturing quite so easily. There are stark differences in how products are structured, the material compositions of products, and actually just the kind of the integration of these things, has become commonplace and joined up for such a long time that to then disassemble those things and it can be more of a challenge. So that's one aspect. There is kind of this cost economy imbalance as well inherently in that process. So moving to that sort of, moving to that sort of system where you didn't design it in the first place can cause really high upfront investment costs. So waste, sorting facilities are expensive. Recycling production lines can be challenging. So doing that properly for all products or all manufactured goods, can be challenging. We're really scratching the surface in what can be recycled. We know that. We want to do more, but it's a high upfront cost, which can be particularly challenging if you're a small or a medium-sized enterprises. So, kind of looking for larger technology companies to maybe take the lead and support, to make it more commonplace. And then I think the third big challenge with this type of circular economy and getting to that is just those supply chain coordination bottlenecks, as it were. So that closed loop process really requires collaboration across different stages of the production process. So, the upstream raw material suppliers need to be involved. The midstream manufacturers, the downstream users all need to be kind of agreeing and able to take on these challenges, to do it properly. So that systematic coordination barrier could persist without some hard work.
Mm-hmm. So we are getting closer to the end of our conversation, but, we had a 2-part discussion, which was, to me, it was extremely interesting. So maybe we can try to give an outlook where we go from here, right? So 2026, I believe, it's going to be a very challenging year. Mm-hmm. There are some persisting issues out there. But of course, we need to look into the future as well. So, according to your research and your experience, what are the major developments you are predicting in the next decade or so?
I'd say there's 4 really big emerging technologies that will be instrumental in sort of fueling this transition to more advanced manufacturing overall. So AI, we've touched upon already. I'll call it out again, but that agentic AI, more effective model training, enhanced model capabilities, end-to-end integration in the manufacturing process, and multi-agent collaboration across those different aspects will be a huge thing. So getting the best out of AI, bringing it together, more reasoning, doing it really properly and solidly is a key part. Digital twin alongside that, so higher twinning accuracy overall, reducing those sort of physical world gaps. It's not possible necessarily to put everything in the digital twin just yet, but those gaps are getting smaller over time, and the real-time abilities of that are getting better all the time. So that's a big thing. And then I'd say physical AI. So that relates more to robotics as well. Easier programming of robotics, path planning, those sorts of things, enhanced task generalization, as we would call it. So increasing reliability of those systems through making, robots handle things more normally through a lower cost way. I think, the easier training of those will undoubtedly lead to more ultimate end users of robotics over time as well. So enhancing the robots experience for a broader set of customers. That's a big thing. I'd say the second big technology is really next generation communications. So 5G, 6G technologies coming through on the wireless side, but then also more or faster hard industrial networks, field buses, real-time gigabit real-time field buses coming through. That's a second thing. I'd say integrating those with increasingly new energy technologies, so more use of alternative fuels, green hydrogen potentially, all solid state batteries, energy storage supporting manufacturing processes will be sort of pivotal in that more of a green transition for manufacturers, especially in those sort of high energy consuming industries. So trying to bring more of alternative fuel technologies to the manufacturing process. And then finally, I'd say more advanced materials, so including high performance composites, nanomaterials, biodegradable materials, bringing those to the fore more. So driving efficiency gains and sustainability more through more cognizant use of better materials. So those are all advancements in technologies and integration that will enhance that whole automation and manufacturing production line experience in a way. So bringing all that together as efficiently as you can would be good.
All right. So that's a very decent outlook on the future. And of course, you can't really predict the future, but the factors that you explain, there are developments happening already, right? I mean, the gigabit industrial network, well, we basically use it already, right? So clearly there will be major shifts happening in this for segments that you just explained. So maybe we could discuss how to act on this, right? So maybe you could provide a little bit of an advice to a potential CEO of a manufacturing company, how to protect their business and how to prepare for the future. Mm-hmm. If you had to, what would be your advice?
I think so. The strategy first approach. So by that I mean embrace IA before AI ultimately. So before you embrace AI, you must embrace, or you can embrace, interact analysis, IA. So in a volatile market, technology can be really a tool, but strategic intelligence can help you, guide you in the right direction. And that's where, we can help. So a CEO must get hands on, not to code necessarily, but to deeply understand really the market shifts and the things that we're describing, the challenges in the market, the workflow challenges, the end customer challenges, understand those, but don't just follow the hype. You can use us interact analysis to filter that noise and to lead with this strategic focus. So that's one key aspect I would say. Prioritize knowledge digitalization over data collection. So don't just collect data from your machines. Try to gather knowledge from your engineers, from your, understanding and appreciation of where you failed in the past. So your goal is to turn your factory into a learning machine ultimately, where AI can ultimately help you to coach your less skilled workers, your junior technicians, to perform like a veteran on day one. So, if you can do more than just automate a task, but actually understand it, then you can start to minimize and hopefully mitigate some of that labor challenge that we've spoken about before. And then I'd say the final thing really is moving beyond individual defense to building more ecosystem resilience. So this broader resilience across your entire system. We've got, very fragmented supply chains, which are trying to consolidate more, granted, but there's a lot of rapid technology shifts that are going on at the same time. So your success really depends upon your ability to draw upon expertise from your entire network. That could be your upstream suppliers. It could be your downstream channel partners. It could be, everything in between. So, a CEO must really lead that charge and that build that deep understanding of collaborations, and use trusted partners like Mitsubishi Electric to, and research experts to build on that. We have expertise that can help to make these challenges easier for you. So your competitive advantage in 2026 is not just your product. It's really that ecosystem and everything that you belong to. So I would say don't try to solve, the biggest challenges on your own in isolation. Seek support from your partners and vendors and so on.
I think you're absolutely right, especially because sometimes there are solutions to problems that are not that obvious, right? So for instance, the point you made about the knowledge transfer, right? The collection of knowledge and then, using that within the company. There are really clever ways where you can adopt AI, almost in a plug and play fashion, right? So, the system can learn from the operator, understand his ways of behavior and so on. And then, I'm not saying that the whole problem is solved because it's a structural problem. But then again, there are ways you can actually do that which simplify your life, right? Therefore, for sure, this kind of need for expertise will be huge. So maybe last question from my side, and we can treat it as a sort of a summary. Because all of that you explained, and clearly there are technological advantages. But in the same time, the typical executive has to manage the ROI in the same time, right? So we have many opportunities where the new technologies are going to solve various problems, but in the same time, there is always the struggle with the ROI. So what's your suggestion how to manage those points?
So in the current economic climate, I'd really say stop betting on that one big sort of moonshot that's going to try and solve everything. It's, there's, as you say, ROI is important. So really start investing in smaller, quicker wins potentially. So instead of like an all factory upgrade and changing everything in one go, try and identify, the most challenging workflows, those critical bottlenecks in your production process, and focus there first. So, find your high value injection molding station and apply AI and predictive maintenance there first. Solve that problem. If you can then, reduce your downtime by 10% over 3 months, then that's your ROI. And then you can then move those savings to focus on the next development. So try and, I would say, break these things down into manageable chunks. And that way you'll hopefully keep your CFO happy while staying innovative and progressing, over time. So don't just chase that hype of, the AI win solving everything in one go. Like, chase the integrity of your data. Think about how you deploy those things. The digital twin or the AI that you're using is only as good as ultimately, the pulse of the factory that it's reflecting. So, it needs to be, handled carefully and well.
Yeah. What you're describing sounds a lot like Kaizen method.
Yes, you could say that for sure.
Yeah. So it's important because it seems like, in the world of all of this technological innovation, still the old ways of starting small are still performing the best, right?
I think it makes, really good sense. So, I would agree.
Thank you, Tim. This was an extremely, extremely interesting conversation. I hope we can do that again, maybe 2027. What do you think?
Sounds great. Thank you, Piotr. Appreciate it.